Good evening, Accelerated Math. We've done lots of problems with lots of fractions in the last few days. And today's lesson is on how do I handle whole numbers that are in fraction operation problems. So please take a minute, make your title on your next page of your math notebook, then put your pencil inside, close it up, and just be ready to listen, think, and concentrate for your I-do's, or for my I-do's, I guess you would say. All right, so we learned the standard algorithm for every operation with fractions. I just want to remind you how they work. With addition and subtraction, remember with those you have to find a common denominator first. Then you just add the numerators or subtract the numerators depending on which kind of problem it is. So that's how those worked. When you multiply, that was the easiest one. You just multiply the numerators and you multiply the denominators. And when you divide fractions, you take the reciprocal of the second fraction, then multiply. So they each had a kind of a different standard algorithm. It can be hard to keep track of which one's which, but hopefully you're getting more accustomed to doing that. So let's do some problems that are going to have a fraction and a whole number in them together. And let me talk through how those work. So let's start with this one. There's a famous relay race in which 4 runners run a total of 2/3 of a mile. How far does each runner go? 4 runners run a total of 2/3 of a mile. So one of the things we talked about in the last lesson was figuring out what operation to do. And so let's kind of start there with this one. I've got a 2/3 of a mile race, total of 2/3 of a mile. And I'm going to divide that among 4 runners. So that is a division problem. I've got to take my 2/3 of a mile and divide it by 4. So with the algorithms here, I could do a model of this. You could probably draw 2/3, divide it into 4 parts, and see how much each one was. I want to talk through the algorithm because the whole number makes it hard. I need to flip my second fraction, take the reciprocal of my second fraction, but it is not a fraction to begin with. So when you've got a whole number in a fraction problem, there's a little trick. Whole numbers actually are fractions. We just don't write them as fractions. What I'm going to do, I'm going to take my whole number, and I'm just going to write it with a denominator of 1. A whole number can just have a denominator of 1. We don't write it, but this is for wholes. And sometimes I need to remember that that denominator is there, even though I don't write it, because I need it to do my algorithm. Because now if I rewrite my 4 that way, as 4 wholes, then it's no problem to take its reciprocal, since I'm dividing. Oops, 2/3 times the reciprocal, 1/4. And I would find out that each runner runs 2/12 of a mile in that race. Sound good? So what I'm going to do, I'm just going to change my whole number into a fraction with a denominator of 1, a denominator of wholes, and then I can do my algorithm no problem. Let's do another one. In a different relay race, each runner runs 2 2/3 miles. How far is the whole race? So in this is a different situation. I've got my 4 runners, and each one runs this far. 4 times 2 2/3. So this has 2 whole numbers in it to deal with. So the first thing I'm going to do to use my algorithm to multiply, the first thing I need to do, I'm going to change this into a fraction with a denominator of 1, 4 wholes times. And I can't really do my algorithm because of this. I can't do my numerator times numerator, denominator times denominator algorithm for multiplying because of the whole number. So I'm going to change this into a fraction too. So this is like saying each whole is 3/3. So this is 3/3 and 3/3 makes 2 wholes and 2/3. So this could be rewritten as the improper fraction 8/3. So now I've got 4 whole runners, each running 8/3 of a mile. Sounds weird to say 8/3 of a mile, but that's really what it is. So that would mean each runner ran, or the whole race rather, was 32/3 of a mile. 33/3 would be 11 miles. So that is 10 2/3 miles, and that seems about right. This is almost 3 miles. 3 times 4 would be 12 miles, a little less. That seems like a reasonable answer. So once again, I take my whole number. The main trick is just to write this denominator we don't usually talk about in for it. Addition and subtraction is quite easy. We're going to do the same thing, and I'll show you, but these are so easy to do, you barely need to. So let's take a problem like this. I run 3/4 of a mile, stop and stretch, and then run 4 more miles. How far do I run? So this is an addition problem, right? I'm going to take this 3/4 before my break, add it to my 4 after a break, and now, honestly, this I think is pretty obvious, that you don't even need to really do that. Because the answer I feel like is fairly obviously 4 3/4 when you add those together. But just in case, I'll show you what you could do. Same thing, I could just rewrite my 4 as 4 wholes. And to add those together now, I would need to find a common denominator. Well, there's an easy common denominator of 4. So I can change that. I can do 3/4 plus, I can change 4 wholes to fourths. And remember, if I'm going to multiply this by 4, I've also got to multiply my numerator times 4. So I end up rewriting 4 as 16/4. Add them together, I get 19/4. And guess what that is? That's 4 3/4. You don't really need to go through all that. I just want to show you that the math kind of works. Same thing with subtraction here. I have 6 bottles of ketchup for a picnic, but only 3/4 of a bottle got used. How much is left? So I've got 6, and I take away 3/4. They're much easier when it's an addition or a subtraction problem, because I think this is kind of intuitively 5 1/4. But if you wanted to, you could change this to 6 wholes minus 3/4. Get your common denominator of 4. 6 times 4, 24/4 minus 3/4 is 21/4, and that is 5 1/4. So addition and subtraction is not really a big deal, but multiplication and division problems, you really do need to know this trick of writing your whole number as a fraction. Otherwise, there's not really another great way to do it. Okay? So I'm going to not do an addition and subtraction ones in the we do, but let's do a division and a multiplication one together so that you can write those down. Okay? I've got 4 ounces of hot chocolate mix. A cup of hot chocolate needs 2/3 of an ounce of mix. How many cups can I make? So let's think through the wording and figure out if this is a multiplication or a division problem. I'd actually love for you to pause, think about it, and decide what you think. I think the way this is wording, I don't have the sort of the of language that lets me multiply. So I think what I'm doing, I'm making as many groups of this as I can. So that sounds to me like 4 ounces divided into groups of 2/3 of an ounce. How many can I make? So I think that's a division problem. So that's not easy for me to do, because I don't, what I want to do, I'm going to flip the second fraction to its reciprocal. So I'm going to do 4 times 3/2. But I can't do my quick numerator and denominator trick unless I change this to 4 wholes times 2/3. Then it's super easy. 4 times 2 is 8. 1 times 3 is 3. I can make 8/3. I didn't do that right. Let me go back. Sorry. I reflipped my second one. 4 wholes times 3 halves. That makes more sense. I can make 12 halves, which is 6 cups of hot chocolate. That seems pretty reasonable. So again, the thing to make note of is this step right here. That I can just consider a whole number to be a fraction and then do stuff like I normally would. Okay? I have 11 bottles of Coke and each one is 3/4 full. How many full bottles of Coke can I make? So this is a repeated addition problem, right? 3/4 for 3/4 plus 3/4 11 times. So that's a multiplication problem. I have 11 times 3/4 or 3/4 times 11. And to do my standard algorithm here, instead of drawing this out, I would just need to convert that to a whole number. 11 wholes times 3/4. And I would get 33/4 bottles. Let's see, 4 times 8 is 32. So that is, I think, 8 whole bottles and 1 more fourth of a bottle. I'll work it out like that. So that's how we handle whole numbers in fraction problems. We just turn them into fractions with a denominator of 1. That's sort of the magic step that's new, is just to remember that we don't write that denominator all the time, but it's there. So once you feel like you've got a handle on how that works and you fully understand it, you are done for the day and we'll do your you-dos at school tomorrow.